So in this video, we're going to solve 2011 AP Calculus AB FRQ question. So it says a car is traveling on a straight road with the velocity of 55 feet per second at time t equals 0. For 0 is less than or equal to t, which is less than or equal to 18 seconds. The car's acceleration, a of t in feet per second squared, is a piecewise linear function defined by the graph above. First question, is the velocity of the car increasing at t equals 2 seconds? Why or why not? So this is a graph of acceleration. So acceleration is the first derivative of velocity. So you need to base it. V prime of 2 is going to be equal to a of 2. Since it's above the axes, it has to be increasing. So you would just specify what it is, which is 15 meters per second squared, right? Which is greater than 0. So therefore, the velocity is increasing. Okay, next part of the question says B, at what time in the interval between 0 and 18, other than t equals 0, is the velocity of the car 55 feet per second? Why? So, what you have to think over here is, at the initial time, v of 0 is equal to 55. So you need to have the same area as the positive area, which is here. Which it looks like it's going to be about here, about 12-ish. Now let's look. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 15, 15. Yep, it has to be there. So what you would say here is, for part B, at time t equals 12 seconds, because v of 12 minus v of 0 is going to equal the integral from 0 to 12 of a of t dt, which equals 0 plus a 55, so it's 55 meters per second. Okay, part C, it says on what time interval does the car have an absolute max in feet per second, and at what time does it occur? So this has to be an endpoint or where the acceleration changes from positive to negative. So you would justify and say v of 0, which equals 55 feet per second, right? And then v of 6 is going to equal 55 plus the integral from 0 to 6 a of t dt, which is equal to 55 plus 1/2, the height is 15, times 6 plus 2, which is equal to 8. Half of 8 is 4. 4 times 15 is 55. So it's 55 plus 60 equals 115 feet per second. And now you would also have to say v of 18. But v of 18 can't be it, because that's really going to be made up of 0 to 12, a of t dt, plus 12 to 18, a of t dt. So when you go back to part C and you actually look at it, this whole thing is plus 55. So it's not going to be less than 0. It's going to be greater than 0, because if you actually figure out the area, let's figure out the area so we're not guessing. 1, 2, 3, 4. So 1/2, let me do my work over here. 1/2, 4 plus 2. Yeah, 4 plus 2 times negative 15, that's negative 45, plus the area of this, which is 2 times 15, half of it, so 15, which is negative 30, plus the 55, which is 25 feet per second. So this has to be your max at t equals 6. Okay, anyway, part D says, on what interval between 0 and 18, if any, is the car's velocity equal to 0? Well, we just kind of proved it. When you look at the area from 0 to 18, you would say nowhere. That was 25, right? Because when you add the 55, so you would say 55 plus 0 to 18 is greater than A of t dt is greater than 0. And also, if you do the minimum, 55 plus 0 to 16, which is the absolute minimum, A of t dt is still going to be greater than 0, because if you do 55 plus negative 45, that's 10 feet per second, which is greater than that. So remember, endpoints can be the min. We already know v of 0 is 55. Might as well write that over here. V of 0 is equal to 55, which is definitely not it. This is not it. So it has to be this part right here. Nowhere. Because that is the absolute min. So let me actually erase those boxes. So when you look at this, nowhere is there going to be a min, because when you check the endpoints from 55 plus 0 to 18 is greater than 0. 55 plus 0 to 16 is also greater than 0. So you're going to get 10 feet per second. So nowhere is that going to work. It's always greater than 0. I'm sorry that this was messy. I don't really have too much room to work on this, and I hope this video helped.